Welcome to Functional Bar. My name is Charles, and in today's video, we're going to be talking about command line basics or command prompt basics for Linux and Mac. First, we're going to talk about why we're lumping Linux and Mac together in this. They are different operating systems for the most part. Why we need to know this to begin with. Why do we need to know what the command prompt is and how to work with it? What's our motivation? Then we're going to talk about how to open the command prompt, how to read the command prompt. We're going to look at some basic commands, the stuff we're going to need in our day-to-day lives as software engineers and aspiring software engineers. Then finally, we're going to wrap up by talking about what an absolute path versus a relative path is. It's just a minor distinction that we just really need to know. So first, why are Linux and Mac lumped together? Linux and Mac are lumped together because under the hood, Mac is mostly BSD. They made a bunch of changes. They've done a bunch of stuff to make it more Apple the Apple users know and love. But under the hood, it's BSD, which is a Unix variant. It's an open source Unix variant. The terminal on Mac then is very similar to what you get on BSD. It's very similar to what you get on Linux. There's only a minor distinction. The shell on Mac by default now is Z shell, which is it's a program that takes what we type and turns it into what the computer actually does. Linux distributions almost always come with Bash by default. Z shell and Bash for our purposes are basically interchangeable. There's some minor differences in the prompt. When you get to programming in a script language, especially if you're doing shell scripting, that's when you start having to worry about some differences. But everything we're going to do in these videos, it's not going to matter at all. Now, there are other shells that people use all over the place. If you have a favorite shell, use that one. That's great. But if you already know how to change your shell, this video is probably going to be, you're probably going to be beyond what we're talking about in this video. So Mac and Linux are lumped together because they're almost the same thing here at this level. So why do we need to know this? What's the point in studying this? We have to know this because as software engineers, well, first of all, let's go with the practical matters, the immediate practical matters. We're going to be installing software, and when we install that software, mostly those tools, the compilers and whatnot, are going to be installed from the command line. There's not generally sometimes there is, but most of the stuff we're going to be doing, we're going to go somewhere, we're going to copy and paste a curl line into the terminal. We're going to use the terminal. We're going to use a command prompt to install our tool chain, and then we're going to interact with our tool chain from the command prompt. Now, there are tools to do this for us to some extent for some programs. The biggest one is going to be an IDE, Integrated Development Environment. Now, IDEs often provide a command prompt window inside of them. There'll be like a pane in the window that has a command prompt, because even if you're using a full-featured IDE, the expectation is you're still going to have to interact with the command prompt. There's just some things you have to get to the command prompt to do, even when programming in a higher level language. Now, there are a couple of places, a couple of IDEs where they take the idea that you should never have to go to the command prompt. Those only work for very specific languages, and they are generally now really a vendor lock-in kind of thing. What happened is you can't make money off a different language now. So if I invent a language of my own, a programming language of my own, I can't make money off of that. But if I'm JetBrains, I can invent Kotlin and then have an IDE that knows Kotlin. And then I can sell that IDE for $500 per user seat, which is roughly what it goes for now. So if the IDE is how a vendor makes money, really. And they tend to be vendor lock-in-y. And there's some benefit to that, right? There's some competition. But for us, as software engineers, there's no benefit to us for only knowing how to work one IDE. That's bad. So what we want to know is we want to know our foundation technologies, the stuff that applies everywhere. We want to spend our time learning something that applies everywhere, not just to JetBrains IDE, not just to Xcode, not just to a Microsoft IDE. We want to focus on learning something that happens everywhere that we can apply to every situation. And indeed, I have found that people who are comfortable with the command line can pick up an IDE and in almost just a few seconds. People who are only comfortable with one IDE have a great deal of difficulty moving to the command line or moving to a different IDE. They're really stuck in that IDE, which limits their career prospects and limits the amount of money they can ultimately make because they're they're specialized in just that one thing. And that's fine if that's what you want your career to be. That's why we're talking about the command line now. I expect most of you don't know what you want your career to be. And if you're a hobbyist, you probably have a lot of things to do. Now, when we talk about editors, we'll talk more about IDEs. I'm not saying don't use an IDE. I'm saying you need to know how to use the command line in addition to the IDE. So, first thing we have to know about the command line or the command prompt is how to open it. And you'll notice I use the terms interchangeably. The command, we open it on most Linux systems or many Linux systems and Mac by going to a program called Terminal. Now I've hit the Tux key on the Windows key if you have a Windows keyboard. On Macintosh, you're going to hit, I think it's Command space, it might be Apple space, one of those two to get to Spotlight, and you're going to type Terminal. Now if you don't see Terminal, that's okay, but for right now, we're just going to look for Terminal. And Terminal's right here, we see it, we can click on it, we can just hit enter, it's going to pop open our terminal. And this is a terminal emulator. Terminals long ago were actual machines that got wired up to a mainframe. And so this is a terminal emulator. It pretends to be one of those machines wired up to our computer on our desk or wherever it happens to be. So that's why it's an emulator. It pretends to be one of those terminals. They've been programs to do this have been around for so many decades now. It's just its own world. I don't know that there's any actual terminal stuff left in it, though we still see it sometimes with in some of the lower level code. Now, if you're on a Plasma desktop or KDE or something like that, the other thing you can try, this is the next most popular one, is Console. And I'm sorry, I don't actually know that Plasma is less popular than GNOME. It's just the one I see second all the time. There's Console. Now, if you have installed something other than GNOME or Plasma desktop, then you should consult your documentation for what terminal emulator you use. KDE, by the way, starts Console with a K, or Plasma, the Plasma desktop starts Console with a K because KDE is what it has historically been called, and they really like to start everything with the letter K. It doesn't mean anything else. It's not the KKK. It's just they like to start words with the letter K because KDE starts with K. And you can go talk to that community for more information. I've left this. You can see it's very similar, first of all. The two programs are almost identical. They look a lot different, and that's intentionally. I've configured them to have different themes, to use different colors, and that's fine. There's usually a way for, like I think in all the systems we're talking about in this video, for you to change all of your colors. There should be like configured themes already that you can click and play with. I'd encourage you to use one of those themes before you just start changing colors willy-nilly. There's something about contrast you have to be aware of, like how well does the color stand out against the background color. So if you have a bunch of dark colors, it gets hard to read for many people. Maybe it's fine for you and that's great, but for many people it wouldn't be. So I'd encourage you to stick with the built-in themes first and play around with that before you start. And that way you know how to get back to it before you start with your custom themes where you can make it where the text is invisible and you never see anything again. And that's that. So KDE, we see Console gives us a command prompt just the same as Terminal for GNOME. It's going to look very similar. The Mac default should be white background with darker colors. And so now I'm going to close this. Now, if you just pick the program you like best, but I don't want to up here to confuse us. So that's it for how to open. It's pretty easy. It's just Terminal or Console. There's probably others out there that I'm not aware of, and you should feel free to use the one you're the most comfortable with. But if you don't know, use Terminal or Console. So how do we read this prompt? Well, first of all, we need to know what the prompt is. So a lot of times, there's a lot of words that get conflated here. Command prompt, command line. You don't hear it much on Linux, but rarely you might hear DOSBox on Linux and Mac just because they don't have DOS, but on Windows it would be called a DOSBox. More specifically, the command prompt is this line right here. It's highly customizable. But if we have a lot of commands above us or just mash enter a bunch, there's a whole bunch of them. So which one do we mean? We mean the one at the bottom with the flashing cursor after it. And that's because that's the only one we can interact with. This is like the command history, what we've typed in the past. And you'll see that when we do more stuff. But for now, what you need to know is it's the bottom one is the one everyone's talking about when they say go to your command prompt. And there's almost always going to be a flashing cursor there. And even that cursor is customizable, so you may have something slightly different. Now, what are the components here? The first email address looking thing, it looks like an email address because long ago, this is how email worked. It is in a very real sense, an email address. But for our purposes, it's our username, @ and our host name. Now, this is important because on Linux systems and systems that derive, or any system that derives from Unix, really, you can easily SSH to a different machine. Now, on that different machine, you may have a different username and you may have a different host name. So my username is Charles. So, you see it right there. That's my username. @ Jarvis-Linux. That's my host name. That's the machine I'm on. Now, it's possible you're actually on a machine that's on the internet and you have a real domain name here. So you might have Jarvis-Linux .somewhere.com instead. And that would be possible. It'd be really unlikely on a home machine, though. Even on production machines, we usually don't expose the machine itself to the actual internet anymore. We have something in between. So you're normally going to see something more like this. Then there's a colon, and that's just a delimiter. It says, okay, we're done with the who and where we are on the internet. Now we've got the home directory, what path we're on this local machine. And I'm going to talk about the home directory in a minute. That tilde just means our home directory. And then the $, that may change depending on your shell a little bit, but here it's just like it's the end of the prompt. And now we have the thing we can type at. Because I've been highlighting stuff, it's not flashing anymore, but we can still type. And that's it for how to read the prompt. And yours may vary just a little bit. So now let's talk about some basic commands. First thing we need to know is how to launch a program. I'm just going to launch my editor here. My editor is Emacs. And we launch a program by typing its name. And we see Emacs opened. Now, on your system, some systems will just bring the existing window to the front when you launch it, and that's just how they work. In this case, it popped open a new window for us, so it's very obvious what's happening. I'm going to close this window because we don't need it. So we launch a program by typing the program's name. Now, I'm going to go in a little bit more depth here, and you can forget it just right after I tell you, and maybe remember it a little bit later when something weird happens. What actually happens is the shell, and the command prompt, the program that gives you the command prompt, goes and looks in something called the search path, or just the path. It's usually called PATH, all in uppercase. And that's it. It'll search through that path, and it'll find any executable program or file named Emacs. And if it doesn't find it, it'll say command not found. If it does find it, it turns it on and says run that program for us. So if you type a command, and nothing happens, then it may be something weird with your path. For our purposes, what we're going to be doing, we will adjust our path when we install software. That should happen automatically, so it's not like we have to edit it ourselves, I don't think. But we may occasionally see command not found, especially if we have a typo, say command not found, or something like this, command not found. So that's fine. That's just the shell telling us, I don't know what you said. We just have to repeat ourselves and be more clear. That's all. So that's all there is for launching a program. It's really easy. We just type its name. So what is a directory? We've been talking about the home directory a lot. So what's a directory? I'm going to run a program, pwd, and that tells us the present working directory. Now, there's a synonym for this, the current working directory. That's probably not a command we have or program we have on our computer. But what we wind up seeing is internal, we'll have get CWD. When we're interacting with system functions, we might see CWD a lot. So I want to make sure you knew about it. But the command is pwd. So after you've been programming for 6 months and all of a sudden need to remember what to type at the command line to get the current working directory, it's pwd for present working directory. And if you're looking for documentation, remember to check the PWD as well as the CWD. So PWD is a program, and it just lists the present working directory or current working directory on its output. And so we can see it's /home/Charles. Now yours may be different. Usually by convention on any Linux system and almost all Unix systems, it's going to be /home is where all users have their home directory. Charles is my username because I'm a specific user. So I have a specific directory. So it's home Charles. And that's my home directory. So home Charles is my home directory. Your home directory might be /users/your username or /home/your username. It may be somewhere completely different depending on which system you're on. And so that's what the home directory is. It's how we find out where we're at, what our present working directory is, but we still haven't talked about what a directory is. A directory is a container that holds files and directories. So we can see home holds a directory, Charles. Now let's go look at our file explorer or file manager. If you're on Plasma, this is probably Thunar. If you're on Mac, it's, I believe, Finder. So this is our home directory. This is the GNOME file manager for what it's worth. This is the home directory. So that's just /home/Charles. And we see a bunch of stuff is in here. And if we double click on source, we see a bunch of stuff is in source, and these are folders. And so if it draws a picture of a folder, that is a directory. These folders are directories. So sometimes you'll hear people call it a folder instead of a directory. I'm going to try to stick with the terminology directory because our commands are present working. D for directory, our mnemonics all involve directory. And we'll have some other commands that use dir or d for directory. So I'm going to stick with directory most of the time, but you see folders here, and that's a perfectly valid synonym. It's just people originally started showing these pictures as folders. This is not a convenient picture for directory, but they serve the same purpose. They just organize files. So a.out just is a program, the default output for one of the compilers. And so we see we have files here in hello worlds, plural, and several different extensions and whatnot. So this is a directory that only has files in it. But if we were to click on this one, we see some folder for the document. I don't know what that is. We can dig down through Go and see if we ever get to any programs. So we have some files. That looks like it's a music file of some sort, but it says mod, so maybe not. And so you see that path up here gets really, really long. We don't want to type it now. If we happen to be dealing with our file manager, there's almost always a way to open a terminal at this location. And in this case, it's these 3 dots, but depending on what file manager you're using, it may be a little bit different. You open in terminal, all of a sudden we see this nonsense here. So we know what path we're in completely, but then it gets a little bit more difficult to read. So we might do something a little bit different. I'm going to close this. So the folders and directories are the same thing. And a folder or directory contains directories and files. And that's it. It's just a container. Now, how do we list the files in our current directory? We saw a bunch of files and folders in our file manager, but how do we list them on the command prompt? And that is ls. This is one of these abbreviations. ls means list. And it lists the files in our current directory that we're looking at. And we can give it different commands and arguments. There's lots of different things you can do here. But for now, we're just going to focus on the basic usage, which is listing the files in our current directory. And then we see darkpastels.shell, desktop documents, downloads, go, a bunch of stuff. It should look really similar because we just saw it in the file manager. There's a couple of different things we can do here. ls-l is for long. And you see these are color coded. Your color coding may vary. This is one of those things, if you change your theme for your terminal, it may look a little bit different, but you should expect directories to have one color and executables to have another. And if you don't know what those mean, this ls-l is going to show us because right up front we see D. This D here in the mode line means that it's a directory. The dash means it's a regular file. Now sometimes there's some extra characters that show up there, rarely. It's safe to ignore them. really fast, the other characters here mean read, write, execute for the user. And then it's the same thing for the group, and then the same thing for other. Now we can see what the user is the first one here, Charles. Group is the second one here, Charles. And that's pretty typical. Your user and group on modern systems are almost always going to be the same name, and it's going to be your username. If you happen to be on a shared system, your group may be something different. But if you're on a personal machine, it's probably going to be the same as your username. The dash here means nothing. You can't do anything. So in this case, it means a user can read the file, write the file, and execute the file. In a directory, we execute a directory by changing into it. So we can go to the directory. If it was a program, it would be, can we launch the program? And we see the group cannot write the directory. The dash means they don't have that permission. They can read the directory and they can go into the directory, but they can't write it. And it's the same for the files. So right here we see Signal Desktop keyring. Now this happens to be GPG. It's not private keys. It's public keys for Signal Desktop repository. So it's fine that everyone can see them. But if it was not public keys, we should have it. We should not allow other people to read it. So the user can read and write it. And then no execute permissions. We can't launch it. It's just a text file. The group can read it only. They can't change it. They can just look at it. And then everyone else, other, I see this sometimes called wheel in older documentation, can also read it. So everyone can read this file. And if you get some weird error messages about permissions, it's good to kind of look here and maybe see what's going on. So that's what ls-l is good for. It's one of the things it's good for. We can also see, again, this is the user. This is a group that associates with the mode lines. We can see the file size. This is in bytes. And then we see the modified time, the last modified time. This is really important. And so this is when you're developing, probably where you're going to use the ls-l most, other than just kind of ls to get a bearing for where you're at. You're probably going to look at the timestamp a lot. Now there's a common sort of development error where you're happily writing a program that generates a file. And you write it, and all it does is generate the file and produce the file, because this is incremental development is good. It's our favorite way to develop. It's the best way to develop because we only change a little bit at a time and then we test it. So we write it once and it produces the file. Then you go write some more code and you run it again and you expect to see something in the file. So you look at the file and there's nothing there. Then you go fight with that and you still have nothing there. Then you go try again and there's still nothing there. Well, at this point, it's past time to look at the modified timestamp, because you're expecting, well, I wrote the file to begin with, it should still be writing. It is completely possible that the file is not being written. So you should check your modified timestamp and make sure that it is recent and not 20 minutes ago when you ran your first test to generate the file and then started changing things and somehow altered the output so it doesn't produce the file. So this modified timestamp is really good for that. And then in systems administrative tasks, it is invaluable to know when the last modified time was, especially in log statements. It's just really one of the key points in helping you track down what's going on and where things might be broken. So we list files in the current directory by typing ls. And we talked about ls-l. I want one more thing. ls-a. A means all. And now you see there's a bunch more stuff. We've got all these dots. Dot, dot, and dot are special directories. Dot means this directory. Dot, dot means the directory above us, the parent directory. And we'll get there when we start changing directories and whatnot. But just to call out, those are things. And then we see a bunch of these things that start with a dot. Dot in Unix systems almost always means it's a hidden file. Usually this is a file that some program maintains for itself. And usually we should not be editing these files that start with a dot. Occasionally we do, like we might edit the .bash RC or the .zshell RC or zrc RC, but would do that rarely. We would rarely need to edit those, and be very careful. Without knowing what you're doing, don't go into bash RC or zrc and start changing things. You can make it where you can't interact with your system anymore. You can break your shell. You can break your terminal. And then we see several other things here. Occasionally we also have programs installed for our user, might be in these dot directories. I tend to put a bunch of stuff in .local. when I install it, instead of user local, because it's a single user machine, I can install it just for me without giving something I downloaded from the internet permissions to the whole system. It can just run for me. That sort of thing floating around. And then, of course, per configuration information for a program that might be installed for the whole system, but it's configuration just for this user, just for me. So that's what -A does, and we can combine flags in most programs. This is pretty common. -LA, we can do it that way or we can do it this way. You should probably get used to the short form. Just -LA, so it's long and everything, and we see our dots are showing up here, and we have all this stuff, and we have our sizes and whatnot. So if you forget everything else, remember ls is how we list files in the current directory, and we just type it and run it. Now, how do we make a directory? Remember, the directory is a container that holds directories and files. Well, I want to, and we use them to organize things, like a filing cabinet might use files to organize things. I tend to prefer like boxes. I need another place to put stuff. Well, for us, in most of these videos, we're talking about a program. So we manage source trees a lot. A source tree is a directory that has source in it, and you'll get the feel for that. You'll see it all the time. This source tree, this, and source tree, that. It's just a directory that contains your source for a specific project. By convention on Unix type systems, and I follow this on Windows systems also, we keep everything in the source directory, src. Now you see we already have one here, but we're going to talk about how to make it. So I'm going to give you the command to make one for yourself. You probably don't have one yet. So the command to make a directory is mkdir. You see we've got more of these abbreviations. These are venerable abbreviations from decades. They're decades old. They've been around for a long time. SRC stands for source. It's how we abbreviate source. It's the directory where we keep source files. And MK means make. You'll see this in source code a lot. It'll be MK something, something, something. That means make something. And then the rest of this command is dir for directory. Again, this is from a long time ago before we had windowed environments or GUIs, graphical user interfaces, and everything was a directory. There were no folders yet. Folders came about when we needed a picture for the directories. So mkdir, make directory. And then we give it an argument, and I'm going to give it source because if you're following along at home, you should do mkdir space source and then hit enter. Now, as we saw, mine already exists. So my make dir source gave an error. Yours should have just done nothing. It would have made the directory, but would have reported nothing. So you probably have your own source directory now. If you didn't see any feedback at all, you have your own source directory. This is an error, and I want everyone to get familiar with seeing errors. They are friendly. They let you know something is wrong. They are not mean. The computer's not yelling at you. It's just saying, I don't understand. I tried to do what you said. I tried to make the directory, but hey, that directory, the file exists. I know it's a directory, but it still says file exists. There's reasons for that we're not going to discuss. So let's look at what happens when we make one that doesn't exist. I'm just going to do source 2. mkdir source 2. That doesn't exist yet. So I'm going to hit that. You see, that's it working. Nothing happened. That's typical. So if nothing happens on the command line, it worked. The change was made. It only tells you if there's an error, which is really helpful once you get used to it. But as a new user, it means we need to double and triple check our commands. And because on these systems, it's ridiculously easy to accidentally delete things. As a modern computer user, we expect that when we tell it to delete something, it'll say, are you sure you want to delete it? Are you absolutely sure? And then it won't delete it. It'll just move it to the recycle bin or something. I'm not telling you how to delete from the command line because there's none of that. It goes away. The file goes away and you can't get it again. So just don't delete for now. And then when you do, reread the command line 3 or 4 times. But anyway, so nothing happened, or it looked like nothing happened. We didn't get any feedback. So something did happen. If I do ls-l again, we do indeed see source 2 is there. So that's all we do to make a directory is mkdir. When we launch our projects, we'll probably let the project management tool, create the directories for us. Occasionally, we might want to create the directory ourselves. I should say, even though by convention source is the folder to put all your source files in, and I encourage everyone to make a directory called source to put all your programming projects in, you can use whatever name you want. It could be Tangerine Dream, but you're going to have to remember that tomorrow or next week that you've decided to keep all your source files in that directory. So it's much easier to just go ahead and remember the convention of src and just to keep it the same on every computer you're at. So now that we know how to make a directory, how do we change directories? And that is cd is all we type. C for change, D for directory, space src for source. So we're going to look in our source directory. I want to call attention real fast. The prompt changed. The path part of our prompt changed. It is tilde/source instead of tilde. So up here it was just tilde. We're in the home directory. We said cd source. Now our prompt has changed. Now it's tilde/source is the directory we're currently in. And I'll type pwd. Remember, present working directory, often called current working directory in other contexts. And we see it's /home/charles/source. So indeed, it's different. We're in a different directory now because cd changes the directory. Let's talk briefly about the ... that we saw a minute ago. If I type cd space ... that says go to the parent directory. Now, in this path, the parent directory is the one to the left. So cd space ... and we're just going to go back to tilde again, or home. So we can do pwd, and we're back in our home directory. And this directory has a parent, cd ... We go back one to the left, and then we see we're in /home. This is on many systems where the directories for all users are going to be. So it's the homes plural might be more meaningful, but historically it's called home. And that makes it look nice when we do pw, like /home/Charles, Charles' home directory. That makes it look nicer there in that context. But in my case, I only have one user on this machine that has a home directory. There's other users that may not have home directories or their programs. And so we see that's right there. That's the home directory. And we can do cd space ... again. And now we're in the root. The root starts with a /. pwd just shows us a /. ls shows us some stuff. Now, I want to call out real fast, if you're in the root directory, you should never change things without really knowing what you're doing. This impacts how your system boots. It impacts how your system figures out what programs to launch. All sorts of things are kept in this root directory that you can, if you change it willy-nilly, you can prevent your system from booting. You'll lose all the data on your machine and you'll have to reinstall. I did that many times as a teenager, and I have no desire to do so again as an adult. So don't change things in root without really knowing what you're doing. For the most part, you should never have to interact with any of these things directly. Usually it's just the top of the file tree. It's the root of the file system. So you'll start from root and go somewhere else. You really want to be in your home directory or something under your home directory for, say, 95% of what you're doing, unless you're a systems administrator. Now, if we're lost, if you're following along at home and you get lost and you want to go home, how do I get to my home directory? cd change directory tilde. Tilde means home. Now, tilde is right below the escape key. You have to hit shift and that one right there. If it's a back tick, is the regular one. Tilde is the shift one. And then you hit enter, and now we see we're back at home. It's really convenient that tilde means home. We could, so I can just cd back there, we could use the long way, the absolute path. Now tilde is an alias, it's a special thing. We could use the absolute path, home/Charles, and indeed we get back to home. Our shell says, oh, you're at tilde, that's home, that means home. And so now we can talk a little bit about what absolute path versus relative path means. The absolute path, I'm going to update us over here. The absolute path always starts with a /. Now, if you're on a Windows system, that would start with a letter, typically. I'm not going to talk about what that means in this video. But on Linux systems, it starts with a /. That means the absolute path, because remember, the / is the top level. It's the address of the top level directory, the root of the file system. Everything else is below that. So that's all an absolute path is. And a relative path is one where we don't put the / in. The tilde here is special. It doesn't count as either. It will evaluate to an absolute path. But let's just ignore that for now. So if we're in the root directory, we could use our absolute path to get home with the cd/home/Charles, or your username, and that'd take us home. But we could also get home by following a relative path. And this is how you might use relative paths. One of the powers of them is we don't have to type out everything at a time. We just type home. Now we're in the home directory, and then probably type ls compulsively, so we know we can look around, and then we can see to in this case Charles. And now we're back in our home directory with the tilde. And then when we normally start our terminal. It should normally start in our home directory, and we want to go to source. And so we go to our source, cd space source, and that's a relative path. We change to source, and we look around and we see a bunch of stuff in here that we could go to. And these are just various things floating around in my source directory. So the absolute path is like a full address, and the relative path is like next door, or down the street, turn left at this sign, right? Relative, I'm giving you directions relative to where we are. A relative path is the same thing. Instructions relative to what directory we're currently in. And the absolute path is like the full address. And so you can see that intuitively they're useful for different things. If you're talking to someone in a different country, or you're going to give someone who's not right next to you instructions, you might give them the full address so they can look it up on their phone, because the phone doesn't know down the street and to the left from where you are. It might next decade, but right now it's a little bit hard for it. So we use these for two very different things. Relative paths are what we're going to use most of the time in our day-to-day lives. And if you're in a source tree, relative paths to other files or directories in that source tree. And you'll build an intuitive understanding what a source tree is. It's just a directory that holds all our content, our programming project and everything under it. And so the relative paths within that source tree are great and super helpful. Most of the time, they're what you want. An absolute path within a source tree is probably bad. And that's because if I take my source tree, you can see my home directory is different from yours, almost certainly. If I take my source tree and send it to you and it has absolute paths in there, you now can't build it. Assuming they're absolute, they're like / like this, you can't build it. URIs, absolute URIs, you could. But at any rate, we don't want absolute paths in the source tree because it means other people can't build it. We don't want relative paths outside the source tree because other people can't build it. Several programs are going to take your relative path and turn them into absolute paths. And that's because there's a lot of ambiguity in a relative path, especially in a build system. Now, build system changes directories often on its own. The thing that actually Make, you've probably heard of Make, or maybe you haven't. There's different ways to build software. Make is a venerable example. It's still very useful. Lots of people use it every day. It's a great program. There are other programs that do something similar depending on your language. Make is generally used for C. CMake is another great example of a build system that's going to change directories, and it will change all your relative paths into absolute paths. So you'll type in relative paths, and then when you run it, it turns it into absolute paths and then executes against the absolute paths, so it knows exactly what's going on. Compilers are the thing you're mostly going to be interacting with every day. They're going to give you an absolute path. And the reason they give you an absolute path is so you know exactly where that file is. So it's really important because lots of programming projects have the same file names. Like package.json is in every node project. And if you happen to have a node project under a node project under a node project, then you've got 3 package.jsons and you don't know which one there is. You might think that sounds silly, but node modules is just node projects under node projects under node projects. That's how they manage their packages in node land, or at least they used to. It's to my memory. So it's and then if you, heaven forbid, you have different projects in the same directory. Like I have several projects here. They're all different things. These happen to all be very different things. But if they're the same thing, they might all have package.yaml in them, or stack.yaml, or any of those things. So we really, really need to know what the absolute path is so we know which one we're talking about without any ambiguity. We don't want to be confused. And sometimes when you're reading those, it's really easy to forget to look. Sometimes when you're looking at a file, you look at the file and it's like, it's not wrong. What are you talking about? go double check the absolute path, because it's easy for you to think it's the file you're looking at right now when it's actually a completely different file with a similar or the same name. So that's when we might use absolute paths versus relative paths. And even though I've got them separated here, they're almost the same topic, because it's hard to talk about one without talking about the other. Absolute paths start with a /. That's how we make an absolute path. And then relative paths don't. We use absolute paths when we want to make sure there's no ambiguity. We use relative paths most of the other times. And we certainly do when we have a source tree and we need to reference files within the source tree. We use relative paths. And now we're basically done. I'm going to really fast talk about what we covered. We lumped Mac and Linux together because from a command prompt perspective, they're extraordinarily similar. They're almost the same. Certainly all the commands we're going to be using are the same on the two systems. We talked about we need to know the command prompt, because once we learn how to interact with stuff on the command prompt, we'll be able to easily transition to any other tool we may want in our career. We may want to for a hobby or in our career or whatever. It's easy to go from the command line to the IDE. It's very difficult to go from the IDE to the command line. We talked about how to open the command prompt, how to get here. It's a program called Terminal most of the time. Could be called KDE, could be called Console if you're on a KDE-like type system or derived system like Plasma. There are a few other out there that all do the same thing. It just sort of depends on what you have installed, but Terminal or Console should work for, I think, probably every user here. We talked about how to read the command prompt, talked about what some of those basic commands are, like how we can ls to list a directory, cd to change directory, mkdir to make a directory. And then we wrapped up by talking about absolute versus relative paths. And it's okay if that's confusing to you right now. You'll build up an understanding as you work with it, but it becomes more and more important later when we make decisions about how to talk about files. And that is that for this video. As always, questions and comments are welcome. Please click like and subscribe. Thank you for watching, and I hope you have a wonderful day.